Hi everyone, welcome to my YouTube channel Zenith GATE Mechanical. So the fourth question in context of balancing rotating and reciprocating masses, which one of the following option is true? Four options are given. A single cylinder IC engine can be completely balancing or completely balanced using a single balance mass. A single cylinder IC engine that can be balanced by two masses. An unbalanced rotor that can be completely balanced using single balancing mass. An unbalanced rotor that can be completely balanced using two balancing masses which are attached in the two distinct plane or two different plane. Okay. So in context of single cylinder IC engine, single cylinder IC engine, single cylinder IC engine having two masses. One is the rotating mass and the second one is the reciprocating mass. Reciprocating mass. Okay, so this rotating mass you can balance by a single mass, but the reciprocating mass you cannot balance by using a single mass, first of all. Second thing is there is no complete balancing. In case of reciprocating mass, you can only do the partial balancing. Okay, so both the options will be wrong. Now the C option is because it is talking about completely balanced. So complete balance cannot be possible in reciprocating masses. An unbalanced rotor, that means the rotating masses that can be completely balanced using a single balancing mass. Yes, this is only possible when the rotors are rotating in the same plane. When they are rotating in the different plane, then the two balancing masses are needed, so that can be attached in the two distinct plane. So the most appropriate answer for this question is an unbalanced rotor that can be completely balanced using the two balancing masses when they are attached in the two distinct plane. And that is nothing but the dynamic balancing. Okay, so the correct answer for this question is to fully balance an unbalanced rotor with dynamic balancing or with dynamic unbalance, two balancing masses, two balancing masses in different plane, in different plane are required. Are required. So the correct answer for this question is option D. Okay. So one more question, and that is the last question from this theory of machine and vibration. The mechanism chapter, an offset slider crank chain mechanism is shown in the figure below. The length of stroke of slider you have to calculate. Okay. So to understand this question, first of all, you have to calculate the extreme position. You have to understood what are the extreme position of this slider. So what is happening actually, this crank is rotating with certain angular velocity. This crank is connected with a connecting rod, and this connecting rod having a joint with the slider. Once the crank is rotating in this direction, this connecting rod will also move. That means the slider will move along this particular axis. Okay, it will do a translation motion along this axis. So what are the given data? So the crank radius is given as crank radius is given as 30 mm. Connecting rod length, which I am denoting with L, is given as 50 mm. And offset value, offset is given as 10 mm. Okay, that means this way. This is the connecting rod length. This is the crank radius. Now, so let me first draw the extreme position of this slider. This is your crank. So one extreme position is when this crank and the connecting rod will be lying in the same line. Okay, that means this slider will be at this point. Okay, the second will be when this crank is rotating like this, that means the slider will reaches at this point. Okay, so the distance between these 2 points is nothing but the stroke length. Okay, let me first draw the two extreme position. So this is the extreme position 1. So I'm denoting with P1, and this is the second extreme position is P2. Okay, so when the slider will be at this point, that is nothing but P1, this distance is nothing but the offset length, which is 10 mm. 10 mm. When the slider is at this position 1, that means this total length will become, this is R and this is L, so L plus R. And when the slider is moving in this direction, so it will reach to this particular position P2. This is the second extreme position. Second extreme position. So what is this particular length? This length is nothing but L minus R. L minus R. So because this slider is nothing but it is moving in this direction. The slider is moving in this direction. So the crank will rotate like this. So this line will be in line with the crank. So what is this distance? This distance is nothing but L minus R only, because this total length is 50 mm. This total is 50 mm, and the crank will reaches here. This is 30. So what is this distance? 20 mm only. Okay. So now I am just representing with L and R. So L minus R. So let us suppose this point is A and this point is B. This point is B. So what is the stroke length in this case? The stroke length, very simple. The stroke length is nothing but AB only, the distance between the two extreme position, which is nothing but, suppose this is the O point. So OB minus OA is the stroke length. If you subtract this distance minus this, then you will get this is nothing but the stroke length. So if I will consider triangle OP2A, OP2A, so can I use the Pythagoras theorem? OP2 square minus AP2 square is equal to OA square. Okay, so this is the hypotenuse, this is perpendicular, this is base. So from here you can easily calculate the OA value. OP2 is nothing but L minus R, which is 20 square, minus AP2 is, this is the offset, 10 square. So OA value is nothing but square root of 300, which is approximately 17.32 mm. Okay. Now, if you consider the triangle OP2B, again, if you use the Pythagoras theorem, can I calculate the OB value? Yes, OB square is nothing but OP1 square minus OB square. What is the OP1 square? This length is 50 and this is 30. So total length will become L plus R is 80 square. What is OB square? That is 10 square. So from here, you can easily calculate the OB value. OB value is nothing but square root of 6300, because 80 square is 6400 and 10 square is 100. So OB value is nothing but 79.373 mm. Okay, so what is the stroke length? Now the stroke length will become OB, which is nothing but 79.373 minus 17.32, which is equal to 62.05 mm. Now, if you see, you have to round off to the nearest integer. That means what is the correct answer for this question? 62.05, the integer value nearest will be 62 only. So the correct answer for this question is 62 value. Okay. So these are the 5 questions asked in the GATE exam 2025 from the theory of machine and vibration. So I have covered all the questions. So thank you so much.